Chapter 16, question 5, asks you to draw the condensed structural formula for several amino acids at a pH below 1. Now remember, the pH scale goes from 0 to 14, where 7 is neutral. So 1 is really acidic. A pH below 1 is going to be below the pI of these amino acids. We'll deal with that part of the question second. First, let's just draw the structural formula of each of these at the pI. And that is what's given in table 16.2. So we're going to draw these exactly as they are on this table. Now notice, for all of these amino acids, valine, cysteine, tyrosine, and this one that's just represented by its one-letter abbreviation, T, that, which is threonine, all these amino acids have the same sort of backbone. They all have the amine, the carboxylic acid, and the one carbon in between. So let's draw that for each of these first. Now this is at the PI, so we'll have to fix this, but we'll just start. So drawing it from that table, it's 3 H's, with an N and a plus sign. Then you have the carbon, right? And then COO minus. And you have carbon and then COO minus, and you have the hydrogen going down. Okay, but that's going to be the case for all of these amino acids. So I'm just going to take that and copy it and paste it. Because that portion is the same in all of the amino acids. Okay, what's different is going to be the R group. So the R group is the one that's highlighted in yellow here. So for valine, we'll look and we'll see, oh, valine has this branch there. So I'm going to copy that branch, see a CH with 2 methyl groups coming off of it. And I'm putting the H's on different sides because this bond is between the carbons. And so I wouldn't want to put the H's there. I guess you could. You want to just make sure that the bond is clearly going to carbon. CYS, that's cysteine. You wouldn't have to know that. You would just have to find the CYS on the table, and you can see that it's CH2SH. For tyrosine, we look for tyrosine, and then we have that right here. So tyrosine, so it has a CH2 and then that benzene ring, and then an OH on it. So the CH2, and then you could kind of think of it as having a phenol. So CH2, then the benzene ring, and then the OH on top. And then T, we'd look for that one-letter abbreviation, and you'd see that it is in threonine. And so threonine will have that C with an OH on it, and then a CH3. And so that would be T, or threonine. So we've drawn all of these amino acids at the pI. Now let's think about the pH being below 1. They're all going to be below their pI. So what happens below the pI? Remember our little table that we came up with first in question number 3. We saw that below the pI, which is where we are, below the pI, you put a hydrogen on the carboxylic acid so that the overall charge is positive. So what we're going to do is we're going to take this negative charge, we're going to get rid of it, and we're going to add that hydrogen there. At a low pH, the solution is acidic. This is a really acidic solution, and an acid wants to add or donate H pluses. And so where would it add them? Well, clearly where there's the negative charge. The plus sign from the hydrogen will neutralize the positive charge, and then you'll have the hydrogen there. And so we erase the negative charge, add the H, erase the negative charge, add the H. And these would be the condensed structural formulas for all of these amino acids at a pH below 1.